All right, boys and girls. So I have been, checking your work. Miss Ugram and I have been checking your work, and we've been, seeing, what you guys are doing and what you need help with. So in response to some of the work I've been looking at over the past few days, I can see that you guys need help with fractions that look like this. Okay, so I want you to take just a look at these three fractions: 12/9, 7/5, and 18/15. And I want you to just take a couple seconds to, notice and wonder things about these fractions, okay? So I hope you have noticed that these fractions, the numerator is more than the denominator in all of them, right? 12 is more than 9. 7 is more than 5, 18 is more than 15. Now, we're not really used to seeing fractions looking like this yet. So I want to show you guys, these used to be called back in the day improper fractions, okay? And what, proper means correct. When you put im in front of it, it means not correct, right? So when we're looking at these fractions, we're noticing that they're not correct because we're used to seeing things like 1/1/2, 3/4, right? 2/6. And with these proper fractions, the denominator is bigger than the numerator. So that's what we're used to seeing. That's what we're used to seeing from 3rd grade. That's what we're used to seeing in the beginning of this module for 4th grade. But now we're moved on. And these fractions now are called, we still do use the word improper fractions, but really what they are is a fraction that is more than one whole, okay? That is what these are. These are representing fractions that are more than a whole when the numerator is bigger than the denominator. So I'm going to show you guys how to change these into something called a mixed number. All right, because I noticed that a lot of you guys did have problems with this. A lot of you guys had problems with doing number bonds correctly. So I'm going to show it first for this one with a number bond, and then for the second one, I'm going to use fraction tiles, okay? So for 12/9, what I want to do is I want to pull out the whole number, the whole, and then I have to kind of record what's left, all right? So I have my one whole and my fraction that's going to be left over. So if I have something, a shape, a candy bar, anything that is divided into 9 equal pieces, ninths, how many ninths would I need on my numerator to equal one whole? Well, we should know anytime the numerator and the denominator are the same, it makes a whole. So my whole is 9 ninths, right? That's one whole. Now think about it. If I just had 9 out of those 12 ninths, how many of those ninths do I have left over? Well, 12 minus 9, or 9 plus what number gets me to 12? Well, I know that 9 plus 3 is 12. So here I have 3 ninths left over. So basically what I'm saying is that 12 ninths is equivalent to one whole with 3 ninths left over, okay? So now I am going to erase that, and I want to show you 7/5 using fraction tiles, okay? So here are my 7/5, right? 1, 2, 3, 4, 5, 6, 7. I have 7/5. Now for this one, I want to pull out the whole. Okay, so how many fifths make a whole? Well, here's my whole. I'm going to line it up, and I can see that 1, 2, 3, 4, 5 fifths make a whole, okay? So 7/5 is equal to one whole, right? And how many of those fifths do I have left over that don't fit in the whole? 1, 2. So what I'm saying here, boys and girls, is that 7/5 is equivalent to or equal to or the same as 1 and 2/5 left over, okay? Now I'm going to show you another way. This is the way that I have definitely taught in the past. It's a way that I think is a little bit more harder. Some kids enjoy it, like they prefer this way. Not requiring you to do it this way by any means. Some of you though, you know, those students that really have a solid foundation of division and fractions, you may want to use this way. Okay, so my next fraction was 18/15, right? So, what I'm going to do is I am going to divide 18 by 15, okay? This is my denominator. This is my numerator. How many groups of 15 fit into 18? Well, I know that only one, right? Because 2 groups of 15 is 30, and 30 is more than 18. So one group of 15 fits into 18. See here, I'm pulling out that one whole. From here, I'm pulling out the one whole. See, one group of 15 15ths fits into 18 15ths, okay? So I'm following my same steps that I've done when I divide, multiply, and subtract, and bring it on down and bring it on back. That, you know, the R means repeat. So one group of 15 fits into 18. 1 times 15 is 15. And now I need to figure out how much I have left over. When I gave out that 15, I have 18 total. Well, 18 minus 15 is 3. Now you're saying, well, what do I do with this now? Well, your leftover, what's remaining, actually becomes your numerator. It becomes your numerator, and your denominator, which is 15, it stays the same because this is showing what's left over, right? So let's take this concept and apply it to a number bond, to pulling out the whole. So when we pulled out the whole 15 15ths, what was left over? Well, 18 minus 15 is 3. So 18 15ths minus 15 15ths is going to be 3 15ths. So this is basically saying that 18 15ths, which is an improper fraction, is equivalent to 1 and 3 15ths as a mixed number. See here? It worked out the same way. I hope this cleared it up for you. I know that actually some of you guys were having difficulty doing this on a number line. So let me show you an example on a number line too, because I know that Melanie had said something yesterday on the Zoom call, and I just want to make sure that, you know, the number line is a little different. So we'll look at that, that 7/5 example again. And we knew that 7/5 was equal to 1 and 2/5, right? Because the 1 was 5/5, and 5/5 plus 2/5 is 7/5. So if I'm going to look at this on a number line, I know that my number line is going to go past 1 because 1 and 2/5 is bigger than 1. So let's say I'll start at the whole number 1 on my number line, and I am going to stop at 2. Okay, see that, how I drew that? Sorry about this. I have to wipe that off later, clean it off. My number line goes from 1 to 2 because I know that 1 and 2/5 is in between 1 and 2. So now I have to think, my whole is from 1 to 2. I'm going to divide my whole into 5 because that's my denominator. My denominator is how many my whole is divided into. So I'm going to divide it into 5. So this is going to be like 1 and 1/5. This is going to be 1 and 2/5. This is going to be 1 and 3/5. And this is going to be 1 and 4/5. And this is, you know, 1 and 5/5, which is equal to 2, right? Because 5/5 is equal to 1, and you already have 1 there. 1 plus 1 is 2. So 7/5 is equivalent to 1 and 2/5. And if I divide my number line from 1 to 2 into fifths, I would just identify 1 and 2/5 as being right here. Now you might also say, Ms. Lahosky, how do I draw out 7/5 as a model? I'm going to show you exactly how to do that right now. We're going to do one more. I want the number line. I want the number bonds. I want drawing it out as a model. Okay, so 7/5. So let's say my whole is divided into fifths. That's not changing. That's not changing. This Number is what your whole is divided into. That's the denominator, all right? That downstairs number. So the whole, here's my 1 whole. I'm going to divide it into fifths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Well, I have 7 fifths. So let's go ahead and shade 7. 1, 2, 3, 4, 5. Hey, wait a second. Didn't I just say we had to shade in 7? But we don't have 7. We only have 5. Oh, I have to make another whole? Is that what you guys are telling me? I need to make another whole. And I need to divide that whole into fifths as well. 1, 2, 3, 4, 5. And how many of those fifths do I need to shade? How do I get from 5 fifths to 7 fifths? I need to shade 2 more. 1, 2. 2 fifths. Okay? So here I want you to look and count with me. 1, 2, 3, 4, 5, 6, 7. This is how you would show 7 fifths as a model. 5 fifths equals 1 whole plus 2 more fifths equals 7 fifths in all. So we would say that 7 fifths is 1 whole plus 2 fifths of another whole. Okay? I hope this helped you guys. Please, please let me know. Okay? Bye.